Good morning, students. In this session, as the continuation of the previous class, we started there. We discussed electromagnetic waves, the concept of displacement current, and the approximately 8 to 9 properties of electromagnetic wave. Yes, that important core concept was discussed in the previous lectures. So, in this session, this lecture, what we are going to discuss is what are the Maxwell's equation and the Hertz experiment to produce or to demonstrate the production of EM waves, electromagnetic waves, that we are going to discuss in this session. So, the first one what we are going to discuss is Maxwell's equation. Maxwell's equations. It's a collection of the various results what we got in electrostatics and magnetostatics. In electrostatics, what we got, children? Gauss law we get it. Yes, a Gauss law for electrostatics. Yes, what it says? The electric flux, that is E vector dot ds vector, is equal to Q enclosed divided by what, children? Epsilon naught. Q enclosed divided by what, children? Epsilon naught. This is the first equation. What we obtained is from the Gauss law for electrostatics. Gauss law. But for what, children? Electrostatics. Electrostatics. Yes, so this is the thing what we obtained from the Gauss law from electrostatics. The next second one is a Gauss law for magnetostatics. That means the magnetic flux will be zero. That we are already discussed in the video lectures. That is B vector dot ds vector, that is equal to 0. So this is a Gauss law for what, children? Is magnetostatics. Gauss law for magnetostatics, or simply we can call it as magnetism. Okay. The next one is in electromagnetic induction we discussed Faraday's law. What the Faraday's law says? EMF is equal to, the induced EMF is equal to a negative of rate of change of magnetic flux. Rate of change of what, children? Magnetic flux. But we know that the EMF is nothing but work done by the battery to move the unit charge throughout the loop or throughout the circuit. Okay, for example, you consider this is some conductor, some wire or some conductor or bulb, something else. This is some conductor, any device. Say for example, you just consider this has to be some electric bulb which is connected with the battery, and the key arrangement is there. So what is this EMF means? Work done by the battery. Work done what, children? By the battery to move the electron. Say for example, electron from one end of the circuit to another end of the circuit. That means work done to move a charge in a closed path or closed loop. That is nothing but what, children? Voltage or EMF. Or the same analogy we can obtain that from electrostatics. We discussed the potential gradient. What the potential gradient formula, children? Electric field equal to minus dV by dx, something like that. Yes. From this we can say that dV is equal to what, children? Minus E into dx, or E dot dx, or you can write cos it has to be 1, then we can write E into dx. Therefore, I can write that this has to be what, children? V is equal to the total potential, V is equal to integral of minus E into dx. Like that we can write. But this electric field is related to electrostatics. The electric field what I am going to write is called the induced electric field. The property of the induced electric field and the electric field corresponding to the electrostatics are entirely different. The properties will be different. But I am just writing this equation for the comparison purpose, how this equation is changed. Therefore, EMF of the battery or cell can be written in terms of electric field. That means we can say that what Faraday's law says that induced EMF is equal to minus of rate of change of magnetic flux. This is the original formula what we got from Faraday's law. What we got from what, children? Faraday's law for EMI. Faraday's law for what, children? Electromagnetic induction. This is the formula what we get it from the electromagnetic induction. But this EMF can be written as, that means EMF is nothing but very similar to voltage. This EMF can be written as the line integral of E into dx. Therefore, this EMF can be written as the line integral of S E vector dot what children? DL vector. That means since it is a line path integral, okay. So therefore E dot DL vector, that is equal to what children? S minus dP by dt minus what children? S minus of S d pi b by S dt. D pi b by what children? Dt. This is the Faraday's equation or a law which is written as to be Maxwell's third equation. But this electric field is called induced electric field. Induced electric field. Yes, electric field. But what is the main difference between this electrostatic field, electric field, and the induced electric field? Means here we said that yes, this is the conservative field, where this one will not be a conservative field. That means work done in a closed path will not be equal to 0, but here work done in a closed path will be 0. So that is the main difference. I wrote this equation here just for the comparison purpose, but the electric field what we are using here is different from the electric field what we are mentioned here in as a third equation of the Maxwell's equations. And the fourth one is as we discussed earlier in the displacement current concept, the modified Ampre's circuital law. That means what children? Is the line integral of B vector dot dl vector, that is equal to mu naught times of is I enclosed. The enclosed current is nothing but what children? I conduction plus I displacement. I displacement is what children? Epsilon naught d pi e, that is rate of change of electric flux between the plates of the capacitor. That and all we know that. So this is the Faraday's law for EMI, and this is for Ampre's Maxwell's equation. Ampre's Maxwell's equation or law, we can say either equation or law. So these four, the group of these four equations are generally called what children? Maxwell's equation, which give the very strong relation between electrostatics or electricity and the magnetism. Yes, there is a correlation between electrostatics and magnetostatics or electric property to the magnetic property. That and all given by the a set of equations known as to be what children? Maxwell's equation. Yes, you just know the concept point is. The another one what we are going to discuss is called as a Hertz experiment. This is it may be a 2-mark category in a CBSE exam point of view. Yes children, Hertz experiment. Hertz experiment. Okay. So what is this Hertz experiment means? We know the properties of, in the previous video we discussed that properties of EM wave. All the oscillating or accelerated charges are source of EM wave. So similarly, that is the conceptual or theoretical information or data given by Maxwell's as predicted by him. But Hertz is the scientist who won the, yes, first to produce the electromagnetic radiations in experimental way. It's very simple. The concept is, or the principle of this one is very simple. That is what children, as we discussed earlier, that accelerated charges are as a source of EM wave, source of what children? Electromagnetic waves or electromagnetic radiations. That is the principle what we used, electromagnetic waves. Source of accelerated charges are source for electromagnetic waves. And next one is a diagram. Yes, the second point is diagram. So in exam point of view, you can give such type of subtopics, you can get more marks. So diagram, you just see that there is a insulated metallic plates, thin plates, which are separated by nearly 50 to 60 centimeter apart. Yes, these are the two plates. Say for example, they are plates P and Q. Yes, these are the two plates P and Q, identical plates, and they are connected by means of a conducting wire, or we can consider that maybe a conducting coil, just like a arrangement. You can consider that has to be either straight wire or just like a turned wire. Yes. So we can see that this will be considered to be another identical arrangements like this, and these are the highly polished metallic sphere, that is sphere 1 and sphere 2. You may consider this has to be a straight wire by just like this, or we can consider that has to be a coil like arrangement, spring like arrangement. Yes, for your understanding purpose, I can write that has to be or I can draw here that has to be a spiral shape, just like a solenoid, like that, inductor like that. Okay, now please see that, children. Yes, now these spheres are connected to the source is connected to the source of high voltage. Yes, that is generally called induction coil. Induction is a coil which can produce the very strong or very high voltages. Okay, so these are, say for example, this is positive and negative terminal. Okay, children. Now what will happen is, whenever the strong potential is given to the spheres which are connected by the wires to the plates P and Q, which are nearly separated by a distance of 50 to 60 centimeter apart. Yes, now what will happen, children? As once this potential is given to these spheres, what will happen? We can see that these plates will act as a capacitor of capacitance C, parallel plate capacitors, and this connecting wire will act as a inductor of inductance L, for example. That means this will act as a LC system, that is inductor capacitor system. Okay. Yes, now you please see that when the strong potential is given, the capacitor may gets the fully charged. After that, what will happen, children? Once the sphere got the very high potential, the air near this between the gaps of the sphere gets ionized. The air molecules near the or between the gaps of the sphere gets what, children? Ionized. Now what will happen? There will be a positive ion, there will be a negative ions surrounded by the gaps of this sphere because of the ionization of the air molecules. Now please see that, children, this connecting wire will act as a inductor and this plate will act as a capacitor. It will make the LC oscillation. You may study it in your oscillation topic in 11th standard. So you just see that when it makes the oscillation, what will happen means the ions between the as a sphere gets oscillates. What will happen whenever the particle gets oscillates? What will happen, children? It has some acceleration. Due to that acceleration, by the concept proposed by the Maxwell's, that means the accelerated charges can emit the electromagnetic waves. So because of that, this LC, these parallel plates and the connecting wires will act as a LC system, LC oscillating system, which accelerates the ionized particles between the gaps of the sphere. Therefore, that ions will get accelerated. Now that accelerated charges can generates the electromagnetic radiation. Generates the what, children? Electromagnetic radiations or EM waves, electromagnetic waves. Okay, children. Now that electromagnetic waves can be detected by a device that is called what, children? As a detector. Okay. So what is the detector means? It's very simple. You can keep some what is that? Any LED or any other what, children? Fluorescence surface or screen. Then we can see that this incident photon or this incident radiation may produce the that fluorescence on the screen, or if you are keeping some LED bulb, we can see that glow in that bulb like that, which shows the emission of electromagnetic radiations from this arrangement. So the frequency of the oscillation, that is nothing but the frequency of the emitted wave, because the frequency of the oscillation is very similar to the frequency of the electromagnetic waves. How fast the charges, ionized particles can oscillate, that frequency is same as to be electromagnetic waves frequency. Therefore, we know that for LC system, we can write that the frequency of this LC system or LC oscillation is given by 1 by 2 pi root over what, children? L into C, where L means inductance value of this connecting wire and C is capacitance value of these plates connected is there. So this frequency is equal to the frequency of the oscillating charge is equal to what, children? Frequency of the electromagnetic waves. Frequency of the what, children? Electromagnetic waves. Okay. So by using this experiment, Hertz produced nearly 10 to the power of 6 hertz, approximately 50 megahertz, like that. The approximate frequency value of the radiation produced by this system by Hertz experiment is approximately 50 megahertz frequency. Okay, children. So this is the experimental demonstration or explanation for the Hertz experiment based on the concept of the accelerated charges are sources for electromagnetic radiation. Okay, children. Yes, this is the brief introduction or the explanations about the Maxwell's equation and the Hertz experiment. Yes, please kindly note down, children.